Okay. That same question we just did with polynomial inequalities. We went through the kind of the long way of solving it. First thing we did was factored, okay? So you'll just have to relook over factoring if you don't quite remember it. But this equation, the first thing we have to do is essentially factor it. When we factor it, we discovered that the factored form of it is x minus 1, 2x minus 3, and x plus 4, correct? Yeah, is greater than 0, okay? This is important. Now, we know we can find x-intercepts is what we did before. Another way we can go about doing this is we know that these, again, on a number line, set several inequalities for us. Or they set up, we'll draw the number line out again. Okay. We know that, essentially, again, we're looking for f at x when it's to the left of negative 4. Okay, in other words, when x is less than negative 4. There's also the option of x being between 1 and 4. Okay, negative 4. Again, we did this in the other question setting this up. This being 3 and 2 when x is between those, 3 and 2 and 1. And again, when x is greater than 3 and 2. What we did is we actually looked for values. We knew that we could get values, well, when x is less than 4. Well, one value we could use is when x is negative 5. We know when x is 0, it falls in here. When x is 1.25, it falls in here. And let's say when x is 2. These all hold true for these kind of breaking points because these are the x-intercepts. So instead of graphing them, putting them into the entire polynomial equation, a faster way to do this is actually look at the factored form of it. We go about putting these into the factored form. So what they've done is they've actually made a factored chart. Okay, so we'll try to put this chart together. Oops. What they do in this chart to do it, to solve this, is they write the factored forms over here. So one of them being x plus 4, another one being x minus 1, and another one being 2x minus 3. These are the all three factored forms, okay? And then the bottom part of this, essentially their product, okay? So product, and you'll see what I mean when I say that. Well, once we've set up our inequalities, we have the option when x is less than negative 4. That's one of them. Okay. Another one is when x is between. When x is between and when x is greater. So we'll write them all out again. This one here being when x is less than 1 but greater than negative 4. When x is less than 3 over 2 but greater than 1. And when x is greater than 3 over 2. What I've written in blue are options to put in. Okay. What I want you to think of is when going through this, we go through this chart. Imagine we do the very first one here. We put 5 in, or sorry, in this case, negative 5. Okay, I'm actually going to write it in, but eventually you'll discover that you can just kind of write the answer. You know what it'll be. So if I were to plug it into this factor alone, I'd get negative 5 plus 4. Would I get a positive or a negative? I'd get essentially negative 1.
Yeah.
Okay, and then into this one here, negative 5 minus 1, what does that give me? Yeah, and then negative, okay, 2 times negative 5 minus 3. Do you know what you're going to get?
10 minus 3.
You get negative 13,
yeah.
okay? What's important is the actual sign. I drew the values in, but the sign is what's going to be very important here, and we're going to draw a reference to this in a second. We essentially have a negative times a negative times a negative. If I multiply 3 negatives together, what type of answer do I get? A positive or a negative? 3 negatives times each other? A negative times a negative is a positive. Then that answer, positive times a negative, is a negative. So their products create a negative. Okay. So really that's what we're looking for, positive and negative. So let's try the next one. When we're 0, I plug 0 in there, I get a positive number. Okay. If I plug 0 into this middle one, I get a negative number. And I plug 0 into the last one, I get a negative number again. When I multiply these, positive times a negative is a negative. Negative times a negative is a positive. Okay, I got a positive term. Blue again. Okay, let's try this again. 1.25. When I add that to 4, I get a positive term. 1.25 minus 1, I'll actually get a positive term. And when I plug it into here, 1.25, we might actually have to do a little bit of the math. That's going to give me a negative 1. Okay. So a positive times a positive is positive, times a negative is a negative. Okay, so we got a negative value. That's important. And then finally, last one, we plug 2 in. This gives me positive, positive, and a positive. Well, we know that's going to be a positive answer. So what we've just discovered is that when x is less than 4, f at x is negative, which we're not looking for. Remember, we're looking for greater than 0. When it's between those values, f at x is positive. Here, f at x is negative. And here, f at x is positive. Positive 5. It's just a positive answer. And the reason for this is because what we've done is in our factored form. Remember, we're looking for, I'm not going to write f at x in this case. What we're going to say is greater than 0, right? We're looking for when this is greater than 0, where our factors were 2x plus 3 minus 1 and x plus 4. Well, if we draw a reference to this, what we were doing in that chart essentially is we were creating, well, in the very first one, this became a negative, this became a negative, and this became a negative. When we multiply a whole bunch of negatives, we know we get a negative, which is less than 0, so that can't be an answer. In the second version, this one became a positive, this became a negative, and this became a negative. When we multiply those all, we get a positive, which is greater than 0. So the goal is we always kind of want to get to whatever our term is, if it's 0. We always kind of want to set these inequalities equal to 0. It helps for this method especially. And that's what we did to go about solving this a fast way, instead of plugging it into all the terms. Does that kind of make sense, the factor chart?